In module 3 we have this one numerical based on safety algorithm. It comes, I guess, under the banker's algorithm or something. So how to solve this safety algorithm? It's not that complicated. Before solving this, starting to solve the problem, I'll just about the code or syntax which is used here. I'll just explain you that so that you will have an idea. From that idea, then for me it won't be like necessary to write again. So whatever is already been solved, from that I can just explain it to you. Or better, let me keep it like this. So now, usually what we have now, how to find the mean max and all, I'll just say while explaining this problem. So the first thing what you do, so you will be having, so whatever the work we have to do, so we use this variable or whatever you say work. Okay, so for this work now, so you will be having some resources available. Okay, so you can see this in the side, this table. So you have this available, so that is whatever inside this ABC are that resources, how many resources, I mean ABC are your some process or something memory space that which has resources and all. Just skip to that names and all, I'll just explain you what it is. So first what you do, work equals to available. So here whatever the things we had in available, that will be assigned to work. So we will be using this work itself again and again. So now what we do, first we will say work equals to available, whatever is it. Then we will consider one process. So first thing again, then what we do is that f of i is we make it as false. If f of I is false, it means it has not got the resource, the processor has not got the required or the requested resource, and the execution is still pending. So if it is true, then it has completed got the data which it resources which it asked for and completed its task and everything. So if it is false, then what you do? So if it is false now, then this resource process will be requesting some resource, not requesting, requiring some resources. So we have to check whatever this processor requires, the resource, the required resources are nothing but your need. So if need of I, okay, if need of I is less than work, we will check this. So whatever work means how much it needs, is it less than equal to whatever we have. So if it is in our thing to give, if we have that much, if we are capable to give them whatever they want, then we will give. If not, we will simply go to next problem. If it is true, we will continue further with this. If it is false, what we do, we just this f of I now it will be incremented, it will just check with the other this what to say process. So if it is true, then what you do, then that here it is written is, then what it does now, then work equals to, suppose if it is true, what happens, all the resources are given to this process, and then after using this process, see now after finishing a task, it won't be having any requirement of those resources. So whatever the resources it was holding, it will just release. So then work will get like increase. So work equals to work plus allocation. I'll just write LLOC, allocation. Then what we make, this f of I was there, right, that it will make as true, and we'll update it in the chart or that queue type thing. So this one thing was there, and another thing will be encountering later. Suppose they will ask like immediately some resource wants this much access, will it can be granted or not. So if it is satisfies the requirements, it will be granted. If not, just you can write it won't be granted immediately. That we will do later. Okay, first we will see how this problem is solved. So now you can see here, so this was the matrix over here. Okay, allocation, max and available. So they will sometimes they won't give the available part. So what happens, they will only give allocation max. Instead of available, they will just write in the question A has this many instances, B has this many instances, this many instances. So there what you have to do, you have to count from that how many instances and max are there. So here from that you have to minus max from that total instances. So if not max, just let me see here, as you can see here, see here. So what they say, A has so here A, B, C, right. Suppose that it's in, okay, so A has 10, B has 5 and C has 7. So totally from here max whatever we give, So from that we'll just calculate and subtract it. So see here, now suppose A was 10, right? I'll just use this pen. So A had initially 10, B had 5, and this C had 7. So yeah, see here how many were used here. Okay, 2 plus 3 plus 2, so 7. So 7 here used, minus 7 here. For B how many were used? 1 2, minus 2. For C how many were used? 5, minus 5. What is remaining? That is here 3, this is 3 2. So this is nothing but which came here. Okay, available, this available part. Okay, I didn't write this allocation max available. So whatever they give, max minus allocation itself we get here. Okay, so this instance total instances minus available. Suppose here according to this question also we can see how many A instances are max. So just add this 6 plus 1 7 8 9 10. So here also we had total 10 instances for A, and for B we had 4 and plus this 10 for B also, 5s, then this 2 2 4 7 12 14. So like that you can see how if it is not given, this if this is not given sometimes, because we need the available matrix to solve. As you saw in that chart now, we say work equals to available. So now you see here, first thing what it does, so need equals to, they have to find need matrix. So need of ij is equals to max minus allocation, this thing minus this. So one by one with the respective bits ABC ABC you have to minus. In some max you might have seen this in the this thing, right, matrix thing and all like that it is. So 002 is there, 004 is there. If you subtract this from this, 4 minus 2, so it will be like 002. So just see this part. So here we got 101. How? So from 201 I will write like this, see, from 201. So don't say it 201, it is not 201. So then here 100 we have. So one only this separately will be subtracted. So this become 1 0. This is 1 itself, 1 minus 0, right? So down part is being subtracted. So we got 101. So I'll just do here once. Then so here that video had got stuck. So I'll just do again. So this 137, right? Just let me write first. Here 137 we have, 842 we have, and 157 we have. Okay, then this respective allocation. Okay, 135 632 143. Okay, so this here, this 2 0 0, here 0 1, this 2. So see, don't subtract these two numbers. Okay, 842 minus 632 like that and all. Sometimes it might be the same answer, but still it's not a good thing because you will get confused. Okay, 7 minus 3 4, this should be 1, this should be 0. Okay, the same thing we got here. I did for last 3. Okay, so now let us continue with this problem. So see here, if you can see here, now first to determine whether the system is in safe state, we use safety algorithm. First we found the need matrix because it was not there, it won't be there usually. Okay, we have to find it always. How to find? Whatever in the table they have given. In table max and allocation will be given obviously. So just subtract allocation from max. So max minus allocation will give your need matrix. So first thing, see, work equals to available. Every time you have to give work equals to available. Why? Because at the end the available part changes, right? Each time the some processor after taking the resource, it releases the resources, right? Available changes, it increases. So we have to say work equals to available. So consider P naught for first one. Initially all are set to false. Okay, so he will check if f of 0 equals to false. Here if that if condition will be there, it checks here. Then need of 0 is less than work. So here this will be your need of this is for 0 1 2 3 4. So it will check if need of 0 is less than work. Work is what is available. So 102 and need is 002. So each bit you have to check one by one. If any one of the bit is not satisfying this condition, then that whole thing is not satisfying itself. Suppose here 3 was there. Okay, so see, first one is 0, that is less than 1, 0 less than equal to 0. 2, if suppose 3 was there, that is less than, it's not less than 2. Okay, it's greater than 2. So whole thing won't be considered. So here it satisfied. Okay, just put one tick simply like this, and then what you have to do, you have to change by writing work equals to work plus allocation. Okay, so see here, work equals to work plus allocation. whatever the allocation was there for P0 in that table, that will be sent here. Okay. Now what happens? Work was 102, so allocation was 002. So see here, coincidentally need and allocation was same. So don't get confused that you will be adding need again itself. No, we are not adding need, we are adding this allocation part. Okay, then what you do, we write the value of work, then f of 0 equals to true. Then we will update this table like this, only this f of 0 becomes true. Now see here, consider P2, same thing. Now I will say work equals to available. So whatever now here, through the help of work, we updated the available, that is nothing but your 104. So if f of 1 is equals to false, then what it checks? Need of 1. So need of 1, so see the need matrix 102. What is your work matrix? 104. So see here, it satisfies the condition, it's less than. Okay, so 1 is equal to 1, 0 equal to 0, 1 less than 4. So now what we do, work equals to work plus allocation. What is the allocation of P1? 100. We will add that 100 in this 104, that becomes 204, and we make this f of 1 as true. So two things becomes true now. Now let's see for P3. So here work equals to available, again we did, because here see, now here only work we found, but available allocation, available was not updated, so we have to write work equals to available. So f of 2 equals to false. Okay, yeah, it is false. So need of 2, we'll see what is need of 2 from the matrix is it's 002 again. 002. Anyhow, first process had request was same, so obviously this also will be granted. It's true itself. Now what work will become? Work plus allocation. What is the allocation of P2? 135. So 135 plus this 204, you will get 339, 3,3,9. So f of 2, we make it as true again. So just remember one thing you write, and just these numbers will be changing. Okay, if it is true, we will write this part, same thing will be changing from the respective place. If it is false, now just put into and go to our next process. Again, after completing all the process, come back to this, then it will be resources will be available. Okay, now let us move on here. So suppose, sorry, here this part was not visible for you, so I will just explain here again. P2 na, so here see here, work is available, updated. F of 2 is false, need of 2 equals to work. So 002 is the need for 2, which is less than equal to work. So yeah, it is less, 0 less than 2, 0 equal to 2, 2 less than 4. Work plus allocation will happen, whatever the allocation thing for P2, right, and that will be added here and updated in this chart, flow chart type thing. So now see, we will consider here P4, P3. So work is available, again we updated the available thing here. If we will check if f of 3 is false, if it is false, we will see the need of 3. So see what is the need of 3? 210. Is it less than equal to available? 339? Yeah, it is, tick mark. Then you go for work equals to work plus allocation. What is the allocation of P3? 639. So now your work is 9611, update in this table, true. Okay, now you make this bit as true and update it. Now P4, last P4. Now we will update again available, work equals to available. Then f of 4 is false. If it is, yeah, true, now check for need of 4 is equals to work, less than equal to work. Need is just 014, so it is less than equal to work, obviously, but simply just put tick mark. Slowly, small thing, no need to show it. Okay, then work equals to work plus allocation, add whatever was allocated from that given table itself, and finally write the table. Okay, now you see here the safety sequence. Now then you have to write the safety sequence. So one by one you saw here, we didn't have to go to next process. So continuously 1 to 4 we every process got the resource and completed the action. So we have safety sequences P0, P1, P2, P3, P4. Now the sub question. So don't just stop this problem here and go to your next part of the module or next questions. They also ask if one suppose to determine the weather can be granted. So some question they ask, right here you see here, safe state. Okay, here and then if P2 arrives for 002, request for 002 of resources, can this be request granted immediately? Now see here, very easy one they have asked, 002, right? Here also we had first thing itself got granted, but yeah, same thing won't come here. So don't just write the same thing and lose marks. So here you have to do this part itself. Okay, here as you can see, this part itself will be is required to do. Similar it is. Okay, instead of need we will be using request. So see here, if request of I is less than equal to need of I, So I indicates that process. Okay, so what was that process? It was process P2. So request of 2 is less than equal to need of 2. What is the request? 002. What is the need? 002. Yeah, it is true. Then it will check. If it is less than need only, then it will go for check with what is available. In available also it is less or not. So you won't take here the last value of available over here. Here you had right 10 10 4. You won't take that. Okay, don't take that. So you in the initial what you had from the table, you will take that, because what they asked immediately P2 arrives. Now it didn't ask if P2 again arrives at the last. At the last it can be granted. No, 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 not like that. Immediately if it comes, so we will be using the first initial available thing. Yeah, it is true here. 0 less than 1, 0 equal to 0, 2 less than 2 equal to 2. So it is true. So now what third thing? First thing we checked if the request is less than need or less than equal to need. Then again second thing we check request is less than equal to available. Now what you do? Third thing, same thing, work equals to available. Now what happens? Now three things happen. Your available, now it gets decreased. Okay, then your allocation that gets increased, and your need also will reduce. Why? How? Because see, why available will be reduced, minus will be there for available. How to remember? So for available you will minus request of 5, for allocation you will add the request, and for need again you will subtract the request. Why? Because see, suppose from the available thing I have something and you need something and I am giving. Now from me things are being reduced, now my resources are being reduced, so available will decrease. Why need is reduced? You needed something, after I gave you, your need is fulfilled, so you don't need anything. So whatever you got, you required things, so that need will reduce. So keep in mind like this, and for need and for available it will be subtracted, for allocation it will be added. Just see here, available equals to available minus request. Similar operation perform, you will write the value, and here again you will see allocation will be increased now, so just change that, you will get this. And need, okay, a need of I is then minus request of I, whatever need subtract will be 0. Now main thing what you have to do, you have to update here. Okay, so see here, I made the same table which is there here. I wrote only for process P2 the allocation was changed here, na, that I will write here. The need was changed here, na, that I will write here. The available was changed, na, that I will write here, and just put one circle. So that's how you do for that second part of that question in this problem. We will see one more problem where things will get I want to say next, the processor will go to next because it is not satisfying the need. So just I will show here. Okay, I won't be explaining this because I have already explained, so that it should be easy for you. Ignore this part, consider from here we have four resources. So A, B, C, D are individual 4 resources and they have their own instances. Now see here, for first, okay, first one true. Okay, same procedure, just see here, you should be able to see in the video, everything was given true. Then second, P1. Now see here, what was the need of P1? It was 075 0750. What was the work? What was the available part? 1532. Is it less than equal to? The condition is not satisfying, that's wrong. So now what we will do, P1 ka we did na, in yellow TV, P2 will go. Okay, so now what happens? Same thing you see. Now check need everything, it is okay. Then work will be changing by adding the allocation part. Okay, it's not visible. Yeah, see, just think, if it is true na, so work will get changed, work plus allocation will happen, same thing. Then this table they will update. Okay, here now P3 will see. Okay, same thing, P3 will get the resource correct. Now see here, we have kept F1 false here, don't change it as true. Okay, F1 is false, make sure that. So P4 also okay, satisfied. Now after P4 execution is over, now you see here what happens na, last available. Now it becomes 2 14 11 8. Okay, 2 14 12 12, sorry, yes, see, it becomes 2 14 12 12. Now aram se we will again consider P2 here, see, and we will see the request. So earlier it was 0752, it was not able to like give the resources, it was less. Now it has, right? Now it will give off. Okay, then we will update this table, same thing. Now here also here safety sequence. Now here see the safety sequence. So earlier everything was given granted at the beginning in like order wise. So we had P 0 not 1 2 3 4 5 4, but here it's not like that. P1 we couldn't get, right, so at the last it came, so it's P0 P2 P3 P4, at the end we have P1. And the same thing, if it is request suddenly came, how it is granted, same thing is written here. Okay, here it is continued, and as you can see here, for which resource it was, then it changed. So we see here 1100, what was our thing, 1520. So what in the question, what they have asked for, if a process P1, okay, P1 request. So here what I will do for P1, after changing here ding line, and I will do like this. And so another question, so just see the questions from the question paper or somewhere and try to solve. So that's how this problem it's solved. If you have any doubts, just let me know. Usually you won't be having, because I made some confusions, but again I cleared immediately after that. If you have any doubts, just skip the writing part, okay, and don't skip the explanation part. So this should help you to understand and write for your exams.